Welcome back, everyone. Today we're going to look at slope-intercept form. Slope-intercept form is just one of the ways that you can write the equation for a line. So if you have a line that has a slope m and a y-intercept 0b, you can write that with the equation y equals mx plus b, where y and x remain as variables and m and b are constants. Let's look at the first example. Write the slope-intercept form for the line shown in the graph. Well, first, let's find the y-intercept. Remember, that's where the line crosses the y-axis, which would be right here. This intercept has the coordinates of 0, -2, which means b for this graph is -2. Now, when you have a graph, it's easiest to find the slope by using rise over run. So, starting at the first point, we'll use the y-intercept. We notice that we need to rise by 1, 2. So our slope, rise by 2. And then we have to run 1, 2. So our slope is 2 divided by 2, or 1. Now that we know m is 1 and b is -2, we can substitute those in to y equals mx plus b for m and b, giving us y equals m, which is 1, x, plus b, which is -2. Then we can simplify. So y equals, remember we don't need the 1 in front of the x, it's implied, so just x, and plus a negative is just -2. So the equation for this line is y equals x minus 2. Let's look at the next example. Here we're asked to sketch a line with the given slope and y coordinate. Then write the slope-intercept form of the line. Well, remember b is the y-intercept, and it's actually a point of the form 0, 2. So we can plot this. From the origin we go up 2. There's our y-intercept. Then, recall with slope, it's easiest to remember it as a fraction, and 1 is the same as 1 over 1. And that's rise over run. So, from our green intercept, we rise 1 and we run 1. So up 1, right 1. And you can continue to do this. Remember, I need lots of points to get somewhat close to a straight line. Now, connect the dots. Okay, so now we need to write the slope-intercept form for this line. Remember, it's in the format y equals mx plus b. Y stays as the variable y. Our m here is 1, so it's 1x, plus our b of 2. And remember, we can simplify. We don't need the 1 in front of the x. So y equals x plus 2. That's the slope-intercept form for this line. Let's look at example 2. First, we need to plot the intercept. Well, the y-intercept is 0, which means it's the point 0, 0, or the origin. And then our slope is 1 over 3. So we rise 1 and run 3. So we count up 1 for the rise and then write 3 for the run. And we can do this another time. Now that I have those 3 points, I connect them and I have the line. Then, to get the slope-intercept form of the line, we substitute in our values. Slope is 1/3, so y equals 1/3 x plus b, which is 0. Well, adding 0 doesn't change anything, so we can simplify this to y equals 1/3 x. And there we have the slope-intercept form for the second graph. Look at this example. Write the equation in slope-intercept form. Identify the slope and the y-intercept. I know there's a little bit of a panic because of all of those fractions. Well, if you hate fractions, eliminate those first. Since they have a common denominator of 2, we can multiply all three terms by 2/1, and we eliminate those fractions. Watch. So 2/1 times 1/2 x plus 2/1 times 3/2 y equals 2/1 times 1. Remember, since we're multiplying all of the terms by the same thing, we're not changing the equation. So our first term, 2/1 times 1/2, those simplify, and we're left with x. Our second term, the 2 in the numerator, simplifies with the 2 in the denominator, leaving us with 3y. And then on the right-hand side of the equal sign, 2 times 1 is 2. Well, now we need to isolate the y in order to have this in slope-intercept form. So let's subtract x from both sides. That leaves us with 3y equals negative x plus 2. I'm going to rewrite that over here. 3y equals negative x plus 2. Now, to isolate y even further, we need to divide each term by 3. That gives us y equals negative x over 3 plus 2/3. Remember, there's always that invisible 1 in front of the x. So we can actually rewrite this as y equals negative 1/3 x plus 2/3. Now we can easily identify the slope and the y-intercept. So our slope is always the value in front of the x, which here is negative 1/3. And then your y-intercept is always a point, 0, and then b. b is the constant by itself, 2/3. So there, we've rewritten the equation in slope-intercept form, and we've identified the slope and the y-intercept. Let's go to the second page. Here we have parallel lines and perpendicular lines. Parallel lines always have the exact same slope. This first line has the equation y equals 2x plus 2. And notice that the slope here is 2. And if we look at the second line, it has the equation y equals 2x minus 1. And the slope is 2. Notice these two lines are parallel and their slope is identical. It's 2. If we look at the perpendicular lines, we should see that their slopes are negative inverses. Our first line, this red one, is y equals negative 1/3 x plus 2. And the second line is y equals 3x minus 1. Well, let's just look at the slopes and compare them. The slope of the first line is negative 1/3. and the slope of the second line is 3. Since these are perpendicular lines, the slopes need to be negative inverses. Remember what an inverse is? If you take this fraction, 1/3, the inverse just means switch the numerator and denominator, or you get -3/1. Well, to be a negative inverse, you would convert that negative sign to a positive. So you'd have 3. And look, the slope of the second line was 3. So they're negative inverses of each other. Or another way to check is to multiply the two slopes. m1 times m2 equals -1 when you multiply them. Let's look at an example. Find the slope-intercept form of the line satisfying the given conditions. First, we need to find a line that is parallel, and it needs to be parallel to the given line y equals 3x plus 1, and we want it to pass through the point 0, 0, the origin. Well, since it's parallel, they're going to have the same slope. So the slope of our first line is 3, which means the slope of our new line needs to be 3. And remember, we need the equation y equals mx plus b. Well, we know our slope, it's 3, so y equals 3x. Do we know our y-intercept? We do. Because this line goes through the origin, 0, 0, that means our intercept is 0. And don't forget to simplify. This is y equals 3x. Now look at example 2. We need to find a perpendicular line. And it needs to be perpendicular to 6x minus 3y equals 18 and pass through this given point. Well, because our given line isn't in y equals mx plus b format, it's going to take us a little more work. We need to rewrite that first, and then we can figure out our slope. So the given line is 6x minus 3y equals 18. And we want to isolate y. So let's subtract 6x from both sides first. That leaves us with -3y equals -6x plus 18. Now we divide by -3 to isolate the y. Make sure you divide all three terms. -3 divided by -3 is just 1, so we're left with y equals -6 divided by -3 is 2x, and 18 divided by -3 is -6. So now we know the slope of this first line. It's 2. And because we know we need a perpendicular slope, we need negative, because our first slope is positive, and then we need the inverse of 2. Well, 2 is the same as 2/1, so the inverse is 1/2. So our new slope needs to be -1/2. So remember that equation, y equals mx plus b. And we know m, so y equals -1/2 x plus b. Well, what's b? We don't know b, and the point we're given isn't an intercept, but it is a point that lies on our given line. So we can plug in that value for x and y and solve for b. So y is -3 and x is 4. We plug those into the equation that we have so far, and then we simplify. -3 equals -1/2 times 4 is -2 plus b. We add 2 to both sides because we're trying to solve for b, and we get -1 equals b. Now we know that y-intercept. So our equation, y equals -1/2 x plus b, well, b is -1. So we simplify, y equals -1/2 x minus 1. So now we're done. This equation, y equals -1/2 x minus 1, is perpendicular to the equation 6x minus 3y equals 18. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.